Yes, today's class is on wave optics and it is special on diffraction, and I'm going to start the 3 on 12 pattern on solution of entrance exam and probable question to be asked for NEET and JEE. First of all, let me give you some important formulae. Only basing upon these 3 formulae, we will apply each and every trick. Minutely follow. So minutely follow the points basing upon which I will do each and every type of the solution. Number 1, theta is equal to lambda by a. This is all from the diffraction, and lot of questions from entrance will be solved upon this formula. Very simple and very few number of formulas are there. Theta is equal to lambda by a, where theta is equal to angular width. Lambda is equal to a sin theta minima for minima, and this is the very important formula, again and again will be used. And again from the center, from the center, it is a bright fringe. You will get dark bright in this way, alternative way, is not it? So the distance of dark bright, it is xn. So if you find out the distance from the center xn for the dark fringe or the dark point or the minima point, so your formula is equal to xn equal to n lambda d by a. Again, this is very important. 2 formulas is very important. Another is, very often this question is asked. So distance of the bright fringe from the center, nth fringe, or number 2, number 5, number 7, whatever the fringe, bright fringe or bright points, is equal to n lambda d by a is equal to dark, and twice n plus 1, just to replace this by twice n plus 1 divided by a into lambda d. So in place of n, you just put twice n plus 1. This will be for bright, and if it is n lambda d by a is already mentioned. This is for dark fringe or dark points. These 2 points are very important, and out of these 2 points we have derived this one, and this is very important point, and it is a trick, shortcut trick, which will be applied later on. When the 2 bright fringe coincides, in my last class I told you, then these 2 will be equal. Say it is third bright and it is fourth bright. For third bright and fourth bright, the value of n will be changed, and these 2 will be equated out. So n of, say it is fifth, this is equal to twice of fifth plus 1 divided by twice, say, into lambda d, and nth of, say, 7, this 2 into 7 plus 1 into lambda d divided by. When there is a point of coincides, then these 2 will be equal. So when you will equate, so these 2 will cancelled out. So you will get twice n plus 1 lambda 1, twice n plus 1 lambda 2. It is the one bright fringe, say 5 7, and this is, say, 5 7. These are coincides bright coincidence of 2 bright fringe, and is that value, and for 2 lambda value will be given to your problem lambda 1. So we need not to do all this, just we will write cancelling out twice n plus 1 lambda 1, twice n plus 1 lambda 2 for bright fringe. That's why I have given this one. And next one is part difference equal to s sin theta, and phi is equal to phi phase angle is equal to lambda by twice into part difference. In earlier chapter we have got, and the value of part difference you put, you will get lambda by twice pi into s sin theta. So this is all about the question. You please go through the question. Question is very long and answer is very short. We will apply the trick. The NEET 2023. Parallel beam of fast moving electron is incident normally on a narrow slit. A screen is placed at large distance from the slit. If the speed of electron, this is upon, if the speed of electron is increased, which one of the following is correct? I have not written the options. I will explain and will tell you the reason. Which one of the following is the correct? We know theta is equal to lambda by d. D means a, and also we know beta is equal to lambda d by d or a. So first of all, theta is the angular width and beta is the fringe, that is width of the fringe. These 2 are related to lambda. So let us link the speed of electron 1 by lambda. That is, we'll forget about other thing. We'll just go to velocity. So if the speed of electron is increased, if velocity is increased, that wavelength will be less. So what's happened with increased velocity? Velocity increase, lambda decrease. So here in the question, speed of electron is increased. If speed of electron is increased, so lambda will decrease. Now from this relation, we get angular width is proportional to lambda and beta is also proportional to lambda. So if speed increases, lambda decreases. If lambda decreases, theta decreases. Means width, angular width. Here you write angular width. Angular width decreases, and beta means width, linear width decreases. So theta is directly related to lambda, and lambda is inversely proportional to mu and directly proportional to inversely proportional to the velocity. So if velocity of the electron increases, lambda will decrease. If lambda decrease, so theta decrease, means angular width decrease. If lambda decrease, beta decrease. Am I right? So in the option, width, angular width and linear width both will decrease. There was a option. The answer, this option is correct. This question it was asked in the NEET 2016. The question is diffraction pattern due to a simple slit width of A. The first minima is observed. Whenever first minima comes, we'll write A sin theta at angle 30 degrees centigrade. When the light of wavelength 500 Armstrong is used, the first secondary maxima degree centigrade, that is lambda is equal to A sin theta or lambda by A equal to sin 30, that is lambda by A is equal to half. So now lambda is equal to A sin theta, and here in the second part it is secondary maxima. For secondary maxima, this will be twice n plus 1 divided by 2 equal to A sin theta. So here n is equal to 1 equal to 3 by 2 A sin theta, that is 3 lambda twice A sin theta. Therefore lambda by A is equal to 2 by 3 sin theta. Now earlier we have put the value lambda by is equal to half, so half is equal to 2 by 3 sin theta, that is sin theta is equal to 3 by 4. Therefore theta is equal to sin inverse 4 by 3 by 4. This is the answer. Question was asked in the PMT. So very simple, but first go through the question. A parallel beam of the monochromatic light of waves of lambda 5000 Armstrong is incident normally on a single slit with 0.00 mm. The light is focused on a lens and the screen is placed on focal plane. The first minima is formed for the angle of diffraction equal to, for what angle of diffraction the first minima will be found if the condition of light of wavelength is this and it is fall normally upon the slits with the width of slits is this much. That is here A is equal to 0.001 centimeter and lambda is equal to 5000 Armstrong. Fall upon from the source and single slits, and after some while it is placed a lens and the screen is placed upon the focal length of the lens. So after this you are asked for what angle of the diffraction theta the the first minima will occur. So we know for first minima, very simple, for first minima, lambda is equal to a sine theta. So here sine theta is equal to lambda by a. Here lambda is equal to, very simple, you just put 5000 into 10 to the power minus, and you convert it into meter, 0.001 into 10 to the power minus 3. So you solve out, you will get it half. So theta is equal to, sine theta is equal to sine 30. Sine 30 is equal to half. Therefore theta is equal to 30. The question is very big, but answer is very simple. The focus point or trick is first minima. Where there is a question, the wavelength of the incident upon single slits of light are focused on the lens and seen in the page focus. For first minima, you write a sin theta. Lambda is equal to a sin theta. Your lambda is given, a is given. You are asked to find out theta. Very simple. Just you convert this into meter, and this is meter. Simple. You are getting half. That sin theta is equal to half means sin 30. That theta is equal to half. In orally you can do. Just on thinking you can do. If lambda is given, a is given, this is given. So this is below. You put the value of sin theta is equal to this divided by this 0, 0, 0 cancel out. So you cancel out, you will get. Now the question, in a single slit diffraction experiment, the width of a slit is reduced half. Which of the following is to be done if the width of the central fringe is to remain constant? You need not to read anything, just your central fringe. What is width of central fringe? Width of central fringe is equal to twice lambda d by a. Not central fringe, width of central maxima. Width of central maxima is twice lambda d by a. This is your main point. Now you are asked the slit's width of the slit, that part is a. If it is reduced to half, the width is made half of the initial. Width is reduced to half. Now what is to be done in the width of central maxima so that it will not change? So this is this. So what's happened? Twice lambda d. D is the distance of the screen and slit. No need to say anything about this. Your slit's width has been reduced to half. So if it is reduced to half, your D should be reduced to half so that it is the same. So your answer should be distance between screen and the slit should be reduced to half if the width of the central maxima is to remain same. If it is remains same and width is made half, width of the slit is made half, and if it is required to keep constant central maxima, width of central maxima, width means that width is to be remain constant, so d must be divided by 2, means distance between slits and the screen should be reduced to half. Very simple. Big question. This is the question, and it is asked in a lot of exam. I have mentioned in the experiment of diffraction at a single slit, if the slit's width is reduced, what reduced width of central maxima, central maxima. Now what is central maxima? Width of central maxima twice pi d by a. And what is angular width? Angular width is equal to lambda by a. So what you are asked, single slit, if the width of the slits, that part a, it is reduced, the the slit's width is reduced. Now central maxima, it has some width. Am I right? Some width. They asked what will be the change in the central maxima. Now what is central maxima? Central maxima equal to twice lambda d by a. If this width is reduced, then theta is inversely proportional to width of the slit. If the width of the slit is reduced, so angular width is increased. So one angular width increase, because a central maxima is also inversely proportional to a, that is the width of a slits. If the width of slits is reduced, the central maxima width of central maxima will increase. Because if it is reduced, you just write the formula, nothing. You are needed to two ranges. Cm is equal to twice pi by lambda a. You are asked a is reduced, Cm is inverse proportional to. If a is reduced, central maxima will increase. Now another option it is given. What is the angular width? Angular width equal to lambda by a. Again it is inversely proportional to a. So you will write angular width also increase. This is the answer. Simple answer. Width of central maxima. Write the formula. See the relation with a. If a is reduced, central maxima width will increase. Angular maxima, in the option it is angular maxima is also given. Sorry, angular width is also given. Angular is equal to lambda by a. If width a decreases, the theta will increase. So the option width of central maxima increase, width of angular width is also increased. CT was asked in CT, and it is very simple question. A single slit phonoper. I am not reading out the question just to see. Third secondary maxima coincides with second secondary maxima. Very early I told you at the very beginning, twice n plus, if it is maxima, then twice n plus 1 lambda 1 is equal to twice n plus lambda 2, because x n is equal to twice n plus 1 divided by 2 lambda d a. Am I right? So if it is third, you place n third, and if it is second, you place at second, you will get two relation. And if it is coincide, that's two will be equal. Then lambda d a will cancel out. Will get this one, twice n plus 1 into lambda in one side and twice n into lambda in other side. So you need not do anything. You just learn it by heart. For bright maxima, secondary maxima, twice n lambda 1 equal to twice n lambda 2. This is the formula. Twice n plus 1 lambda 1, twice n plus 1 lambda 2. So the for part value of wavelength, third secondary maxima in the diffraction coincides with the second maxima. So for second maxima, this is equal to 2 into 4 and 1 5 lambda, and second maxima is the first, third maxima is the second. This is second and this is third. Am I right? So second maxima produced from the light wave, white light wave. You are given on the light of wavelength. Here wavelength was missing. I did not forget to write wavelength. So you are given second maxima for wavelength this. So if it's second, so 2 to the 4 and 5 and lambda is equal to 500. 5 into 500 divided by, this is lambda 2. This is third maxima, 3 into 2 into 7. So this is divided by 7. If you, very simple, the seems to be a very hard question, but very simple answer. Twice n plus 1, you put 2 here, you put 3 here, and value of lambda is this, means 5 into this divided by 7 is equal to this. In so orally you can do it. In the mental calculation you can give. You divide it 25 divided by 4, you will get this one. Am I right? So answer is very simple. AMU medical exam, this question is asked, and it is very important and very fine question, I think. If diffraction pattern is obtained using beam of red light, here red light, what happens if red light is replaced by blue light? So you know wavelength of red light is greater than wavelength of B light. So what's happened here? Beta is equal to lambda d by D. It is known to you all. So fringe width V is equal to this. So beta is directly proportional to lambda. So here for red light, it is lambda R is greater than lambda B, blue light. So when you are using blue light, so wavelength is less. Wavelength is less means fringe is less, means smaller fringe বা narrower fringe will be formed. Simple answer, nothing to explain. Narrower fringe or crowded fringe, side by side, they will be side by side. This is very simple question in the PMT asks the condition of diffraction and lots of option is given. Answer, size of the obstacle means that is obstacle or the width of the slit. Size of the obstacle means width of the fringe is at the very first class. Before of that one I told you size of the obstacle is approximately equal to lambda. That is a lambda should be wavelength of the source of light should be comparable with the width of slits. Almost equal to lambda. This is the condition of diffraction. The question seems to be very hard and it is very simple. Just you follow the tree. It was asked in IIT JEE Aligarh Muslim University Medical College, NEET, Karnataka 2013. So what happens? A parallel monochromatic light is incident normally on the narrow slit. A diffraction pattern is formed on the source perpendicular direction of the incident beam. At the first maxima pattern, the phase difference between the rays coming from the edge of the slit is, what is phase difference? I told you path difference is equal to a sin theta at the very beginning when I wrote the formula, and phase difference phi is equal to lambda by twice pi into path difference. So lambda by twice pi into a sin theta. Am I right? So you are asked what is the phase difference? Now to solve out this problem, we will write path difference equal to a by sin theta, and we know phi is equal to twice pi lambda into path difference. So this is twice pi by lambda into path difference a sin theta. Now question is how to calculate the value of sin theta. We know lambda is equal to a sin theta. Therefore sin theta is equal to lambda by a. So twice pi by lambda a into lambda by a. Nothing. Very huge problem is there. Just you write the formula of path difference twice pi by lambda into a sin theta and try to find out sin theta is equal to lambda is equal to sin theta. From where you write value of sin theta, put this value, you will get this. Pi is equal to twice pi. Phi is equal to twice pi. So a huge problem can be solved within a second. So this is all about the trick on the 12 pattern of the question which are asked in different type of entrance exam, and some of the questions which I suppose to be very important which may be asked in the entrance exam I have solved along with the trick. Thanks a lot for watching the class, and I request you to subscribe the class to get another set of more interesting class and which will be on polarization of light. Thanks.